In this lesson, we will learn about Active Directory site. We will start the lesson with answering the question, what is an Active Directory site? Then we will learn about the Active Directory site characteristics and functions. After that, we will evaluate the current site structure in our AD forest. And finally, we sum up our lesson with the keynotes. So what is an Active Directory site? In Active Directory structure, site is a component to group domain controllers together. When we promote the first domain controller in an ID forest, there is no site name option because the DC promo process will create a new site with the name default first site named. After the first domain controller is created, we can log in and modify the default first site name to a name that matches our site naming convention. Later on, when we promote a new domain controller, the site name option shows up for us to select the site for the domain controller, which put it in the same or different site with the existing domain controllers. After a domain controller is promoted, we can always move it from one site to another to match with its network location. Let's learn about Active Directory site characteristics and functions. Domain controllers in a site form partnership with each other and replicate their chains instantly. Within a site, the replication data is not compressed, which means it consumes significant amount of bandwidth. For example, when we promote domain controllers in Chicago subnet and put them in Chicago site, they will form partnership with each other. Similarly, when we promote domain controllers in Elgin subnet and put them in Elgin site, they will form partnership with each other. Now, when there is a configuration change happened on CPVDC01, the change will be replicated to CPVDC02 and CPVDC11 right away, and the replication data is not compressed. Similarly, when we added a new object on LHPVDC02, the new objects will be replicated to LHPVDC03 without being compressed. A domain controller in each site is elected as a bridgehead server. The bridgehead servers form partnership with each other and replicate their changes based on the replication schedule. Between sites, the replication data is compressed, which means it consumes less amount of bandwidth. For example, in Chicago site, CPVDC11 is elected as the bridgehead server, and in Elgin site, LHPVDC02 is elected as the bridgehead server. They will form partnership with each other, and we configure the replication schedule is every 60 minutes between the two sites. Now, when there is a configuration change happen on CPVDC11, the change will be replicated to CPVDC01 and CPVDC02 right away without compressing the data. However, CPVDC11 will wait for the next replication schedule, then compress the data and replicate it to LHPVDC02. Upon receiving the data, LHPVDC02 will decompress it and send it to LHPVDC03 right away. A site is associated with one or more IP subnets. Clients in the subnets locate domain controllers in the site for log-on services and directory searches. For example, in Chicago site, we associated it with the subnet 10.0.0.0/23 and 10.172.0.0/23. And in Elgin side, we associated it with the subnet 10.20.0.0/23. Now we have a client computer that is assigned with the IP address 10.172.0.100/20. So this IP address belongs to the subnet 10.172.0.0/20. So the client knows that it belongs to Chicago site and it will query one of the domain controllers in Chicago site for log-on services and directory searches. Let's verify the current site settings for our AD4S. To do that, we need to open Active Directory, Sites and Services. As you can see, currently we have only one site, which is the default site with the name default first site name. Let's expand it and click on servers. As you can see, here are all the servers in the site. Based on our verification, here is the current site settings in our AD4S. All the domain controllers belong to one site with the name default first site name, which means domain controllers establish partnership with each other and replicate their changes in form of uncompressing data instantly. Clients can locate any domain controllers for log-on services and directory searches. To understand the impact of the current site settings, we must analyze the physical network. Here is the physical network of our AD4S, where we have Chicago as the data center and it hosts public apps and file share. There is no users in Chicago. Elgin is an office that has 200 users and it has computers and printers. Aurora is another office that has 500 users and it has computers and printers. The connection between Elgin and Chicago is the T1 connection and it has 1.5 megabit per second. The connection between Chicago and Aurora is the fiber connection and it has 5 megabit per second. As you can see, users in Elgin Office and Aurora Office must access the public apps and file shares hosted in Chicago Data Center via their WAN links, which makes the T1 links is fully occupied during business hours. By knowing the physical network, we can figure out that the current site settings will cause at least two problems. The first problem is that it allows DCs to replicate their changes immediately and the changed data is not compressed, so it takes forever for the replication to or from Elgin DCs to complete. The second problem is that client can locate any domain controllers in the forest, which make users who are not in Elgin Office experience slow log-on, slow directory searches if their computers served by Elgin DCs. For example, we have a laptop that is connected to the network via the VPN, and it is assigned the IP address 10.172.0.100/20. When querying its DNS server for a domain controller, the client may choose LHPVDC02 to log on. However, the T1 connection is occupied by the application and file share access along with the replication data, so it takes forever for the users to log on. We must update the site settings to reflect the physical network. This is the end of this lesson. Let's read the keynotes